Okay, hi everyone, welcome back to this video series on data centers. Internet Control Message Protocol, ICMP. Internet Control Message Protocol, ICP, works at the network layer and is used by IP for many different services. ICMP is a management protocol and messaging service provider for IP. Its messages are carried as IP datagrams. RFC 1256 is an annex to ICMP, which affords hosts extended capability in discovering routes to gateways. ICMP packets have the following characteristics. They can provide hosts with information about network problems. They are encapsulated within IP datagrams. The following are some common events and messages that ICMP relates to. Destination unreachable. If a router can't send an IP datagram any further, it uses ICMP to send a message back to the sender, advising it of the situation. For example, take a look at figure 4.9, which shows that interface E0 of the lab B router is down. ICMP error message is sent to the sending host remote computer. E0 on lab B is down. Host A is trying to communicate with host B. What happens? When host A sends a packet destined for host B, the lab B router will send an ICMP destination unreachable message back to the sending device, host A. In this example, buffer full source Quence. If a router's memory buffer for receiving incoming datagrams is full, it will use ICMP to send out this message until the congestion abates. Hops time exceeded. Each time IP datagram is allotted a certain number of routes called hops to pass through. If it reaches its limit of hops before arriving at its destination, the last router to receive that datagram deletes it. The executioner router uses ICMP to send out arbitrary message informing the sending machine of the device of its datagram ping. Packet interior grouper ring uses ICMP echo request and reply messages to check the physical and logical connectivity of machines on an internetwork. Traceroute using ICMP timeouts. Traceroute is used to discover the path a packet takes as it traverses an internetwork. The following data is from a network analyzer catching an ICMP echo request. Flags 0x00, status 0x00, packet length 78, timestamp 14/02/25, 12th of the 20th 03, destination 000A0246E0FA8, source 0080C7A3F0D3, ether type 0800 IP header internet protocol datagram version 4, header length 5, precedence 8, type of service %000, unused %00, total length 60, identifier 56325, fragmentation flags %000, fragment offset 0, time to live 32, IP type 0x01, ICMP header checksum 0x2DF0, source IP address 100.100.100.2, destination IP address 100.100.100.1, no internet datagram options. ICMP Internet Control Message Protocol, ICMP 8 echo request code 0, checksum 0x395C, identifier 0x0300, sequence number 4352, ICMP data arena. Frame check sequence 0x00000000. notice anything unusual? Did you catch the fact that even though ICMP works at the internet network layer, it still uses IP to do the ping request? The type of field in the IP header is 0x01, which specifies that the data we're carrying is owned by the ICMP protocol. Remember, just as all roads lead to Rome, all segments or data must go through IP. If you remember reading about the data link layer and the different frame types in chapter 2, you should be able to look at the preceding trace and tell what type of Ethernet frame this is. The only fields are destination hardware address, source address, and ether type. The only frame that uses an ether type field exclusively is an Ethernet 2 frame. But before we get into the ARP protocol, let's take another look at ICMP in action. Server 1, 10.1.2.24 telnets to 10.1.1.5 from a DOS prompt. What do you think server 1 will receive as a response? And server 1 will send the telnet data to the default gateway, which is the router. The router will drop the packet because there isn't a network 10.1.1.0 in the routing table. Because of this, server 1 will receive a destination host unreachable back from ICMP. Address Resolution Protocol, ARP. Address Resolution Protocol finds a hardware address from a known IP address. Here's how it works out. When IP has a datagram to send, it must inform a network access protocol such as Ethernet or wireless of the destination's hardware address on the local network. It has already informed the upper layer protocols of the destination's IP address. If IP doesn't find the destination host hardware address in the ARP cache, it uses ARP to find this information. As IP is detected, ARP interrogates the local network by sending out a broadcast asking the machine with the specified IP address to reply with its hardware address. So basically, ARP translates the software IP address into a hardware address, for example, the destination machine's Ethernet board address, and from it deduces its whereabouts on the LAN by broadcasting from this address. Figure 4.11 shows how ARP looks to a local network. The following trace shows an ARP broadcast. Notice that the destination hardware address is unknown and is all F's in hex and 1's in binary, and is a hardware address broadcast. Flags 0x00, status 0x00, packet length 64, timestamp 9/17/29 12 to the 603, Ethernet header, destination Ethernet address, Ethernet broadcast, source port 00A0244860A5, protocol type 0x0806 IP ARP. ARP address resolution protocol, hardware 1 Ethernet 10 MP, protocol 0x0800 IP, hardware address length 6, protocol address length 4, operation 1, ARP request. Sender hardware address 00A0244860A5. Sender internet address 172.16.10.3. Target hardware address 00000 ignored. Target internet address 17.16.10.10. Frame check sequence 0x00000000. Reverse address resolution protocol. When an IP machines happen to be a diskless machine, it has no way to initially knowing its IP address, but it does know its MAC address. Reverse address resolution protocol, ARP, as shown in figure 4.2, discovers the identity of the IP address for diskless machines by sending out a packet that includes its MAC address and a request for the IP address assigned to that MAC address. A designated machine called an RARP server responds with the answer, and the identity crisis is over. RARP uses the information it does know about the machine's MAC address to learn its IP address and complete the machine ID's portrait. Proxy Address Resolution Protocol, Proxy ARP. On a network, your host can't have more than one default gateway configured. Think about this. What if the default gateway router happens to go down? The host won't just start sending to another router automatically. You've got to reconfigure that host. But Proxy ARP can actually help machines on a subnet reach remote subnets without configuring routing or even a default gateway. One advantage of using Proxy ARP is that it can be added to a single router on a network without disturbing the routing tables of all other routers that live there too, but there's a serious downside to using Proxy ARP. Using Proxy ARP will definitely increase the amount of traffic on your network segment, and hosts will have a larger ARP table than usual in order to handle all the IP to MAC address mappings, and Proxy ARP is configured on all Cisco routers by default. You should disable it if you don't think you're going to use it. One last thought on Proxy ARP. Proxy ARP isn't really a separate protocol, it's a separate service run by routers on behalf of other devices, usually PCs, that are separated from their query to another device by a router, although they think they share the subnet with their remote device. This lets the router provide its own MAC address in response to ARP queries attempting to resolve a distant IP address to a functional MAC address. Summary: we've really covered a lot of ground in this chapter, but understand that the information in this chapter is key. Being able to navigate through the rest of this book, there is still a lot of ground to cover, so make sure you've got it all down and get ready for more. What we're doing is building a foundation, and you want a strong foundation right after you learned about the DoD model, the layers and the associated protocols. You learned about the oh so important IP addressing. I discuss in detail the difference between each class of addresses and how to find a network address, broadcast address, and valid host range. So I'm going to leave it here today for this video. If you like listening, please consider liking and subscribing. Thank you.